Here's another example on how to find vertical asymptotes or wholes. We're going to start with this function. Notice this function is already factored out for you, so you don't have to go through the trouble of factoring. When we're finding vertical asymptotes, remember we work with the denominator. We equal the denominator to 0. Already before I start looking for asymptotes, I can see that I have a factor of x plus 3 in the numerator and a factor of x plus 3 in the denominator. Already I know that I will have a 0 in the numerator and a 0 in the denominator because they share this factor. And already, without doing anything, I know that x equal negative 3 is going to cause those zeros in the numerator and the denominator. And another thing I see is that x plus 3 and x plus 3 both have the same multiplicity. They're both multiplicity 1. So already, without doing anything, just by looking at these factors, I know that I will have a whole at x equal negative 3. That means I'm going to have to look at where this whole is specifically, and also I will have some vertical asymptotes. I already know I'll have a vertical asymptote at x equal 5 and one at x equal negative 4, because none of these will make the numerator 0. Okay, so this is the advantage of already having it factored. You could kind of have a feeling or a notion of what this function is going to do. You can see the vertical asymptotes very quickly. You can see the wholes, or at least try and evaluate if they are wholes or vertical asymptotes very quickly. Let's go through the steps though. Let's start by looking for vertical asymptotes, and to do that we set the denominator equal to 0. We write x minus 5 times x plus 4 times x plus 3. And by the zero product property, I can solve each one of these factors. X minus 5 equals 0. That means x is going to equal 5. X plus 4 equals 0. X equals negative 4. And x plus 3 equals 0. X equals negative 3. Those are my three possible, remember these are possible vertical asymptotes. Now I take each one of these and I substitute in the numerator and see if I get 0. When I substitute 5 in the numerator, I already know if I substitute 5 in the denominator, I will get 0 in the denominator. Now I'm going to check if I get 0 in the numerator. So I'll have 8 here, 5 plus 3, that's 8, and 5 minus 3 is 2, and 8 times 2 is 16. I do not get 0 in the numerator. I also know I was not going to get a 0 because there's not a factor of x minus 5 in the numerator. Okay, so I don't get a 0 in the numerator. Automatically, I have a vertical asymptote at x equal 5. Okay, done. Let's check our other one. This one here, negative 4. Substitute in the numerator, you don't get 0. You get negative 4 plus 3, negative 1. Negative 4 minus 3, negative 7. Negative 1 minus negative times negative 7 is positive 7. So I don't get a 0 in the numerator. Done. That means that I also have a vertical asymptote at x equal negative 4. So far I have two vertical asymptotes for this function. Now I check my last 0 here, which is x equal to negative 3. When I plug in x equal to negative 3 in the numerator, I get negative 3 plus 3, that makes this 0. And negative 3 minus 3 is negative 6. 0 times negative 6, that equals 0. So I got a 0 in the numerator and in the denominator when I use this x. That means that this could be a vertical asymptote or it could be a whole. How do I know? Well, I have to check the multiplicities. We have to go one step further. What I do is I check the multiplicity of x plus 3 in the numerator and the denominator. The multiplicity in the numerator is 1. The multiplicity in the denominator is also 1, so they have the same multiplicity. If the multiplicity of the 0 in the numerator is greater than or equal to the multiplicity of that 0 in the denominator, then I can say this is a whole. Otherwise, it's a vertical asymptote. So I have a hole at x equal -3. And remember, the hole is somewhere on the coordinate plane. I know the x coordinate. I don't know the y coordinate. So if we want to be a little bit more precise, I can locate exactly where the hole is. To do that, this is what we do. We take our original function and we write it in simplified form. What does that mean? That means I cancel out the common terms, right? X plus 3 and x plus 3, I can cancel out. And I'm left with this function, x minus 3 over x minus 5 times x plus 4. And I have to be specific and say, okay, this is the same function as the original, but x cannot be -3. Make sure to say it because now I don't see that in my function. It's not there. The factors that tell me that are gone, okay? But I still have to be very specific and say for this function, x can't be -3. So, and we had said in the last video that this original function, the whole thing is equivalent to this one with this limitation. So if I graph this whole thing using any graphing software that you might download, if you graph this whole thing and you graph this other one, you will get exactly the same graph, the same drawing, except this one will have a hole at -3 somewhere on the coordinate plane with an x coordinate of -3. Most softwares will not show you the hole. They will just show you the straight line. But we know by our mathematical procedure here that we have a hole. Okay, so to find the y coordinate, I write this in simplified form by canceling out the common factors. Here's my simplified form. And now what I do is I evaluate this simplified form at the value of x that I know the hole is in. So I take -3 and I plug it in anywhere there's an x in this simplified form, okay? So what I'm doing is I'm evaluating f of -3 is equal to, and I'm going to use this simplified function. Anywhere there's an x, I plug in -3 minus 3, and in the denominator, -3 minus 5 times -3 plus 4. And that equals -6 in the numerator, and in the denominator you'll get -8 times +1, which is -8. And we can reduce this. This is going to be +3/4. So where is my hole exactly? At -3/4. Okay? And we're done. I know where my vertical asymptotes are, and I know where my hole is. Here's my hole at -3/4. I hope this example helps you. What I recommend is try it on your own, go through the steps, and then you can fast forward the video and see if you got the answer. If you didn't get the answer, go back and listen to it again. Have fun. I will give you one more example of a partially factored function, and then I'll go on to explain horizontal asymptotes. See you in the next video.